So today we are proving triangles similar by different postulates. We're going to do all three today. So the first one is the angle-angle similarity postulate. It states if two angles of one triangle are congruent to two angles of another, then the triangles are similar. Remember, similar is different than congruent. We've been talking about scale figures and similar figures. So if you remember when we did our congruence postulates, AAA was not one, and I said we'll come back to that later, and today is later. So if you can show two angles of one triangle are congruent to two angles of another triangle, you can conclude the triangles are similar by AA similarity. This does not work with other polygons. It only works with triangles. So there's your first one, AA similarity. The other two are SSS and SAS similarity. If you look over here, you see that little squiggle there that we talked about meaning similar. You have to include that. If you just write SAS, that means you're telling me they're congruent. That's fine if they're congruent. But if you're trying to use it to prove they're similar, you have to use that. So you may want to write that down or put a star. You need that squiggle if you're using that to prove they're similar. So you can see I have some triangles here. You may need to draw those. Again, remember you're watching a video, so you can always push pause if I'm going too quickly. So just like when we did SAS congruence, you need that angle that's congruent to be between the sides. It's called the included angle. And if you're not sure, Mrs. Renfrey, how do I know which of these sides to compare? 15 is the bigger of these two. So when you're writing your ratio, compare it with 5, the bigger of these two. So that's how I knew to put 15 over 5, since those are the larger when I compare the two sides. So I have the congruent angles. You'll see that my ratios both reduced to the same 3:1. So we can conclude the triangles are similar by SAS similarity. And the last one is side-side-side similarity. Again, we are going to set up some ratios. And again, if you get confused, because it can be difficult, because what if DEF was flipped upside down? How do I know which numbers to match up? You'll see me in the future slides. I write like S, M, and L for small, medium, and large. And if you remember when we did inequalities, we did that same idea to help us organize our thoughts. So I did the smallest side to the smallest side. That was this first ratio right here. And then I reduced it, medium to medium, large to large. You can see all of them reduced to a 3:2 ratio. So that means the triangles are similar by SSS similarity. On this slide, you're going to see if you can prove the triangles are similar. If you're not sure what triangles, this is one problem right here. And the triangles I'm talking about are this small triangle and then the larger triangle. So you're seeing if you can prove these triangles congruent. I know it looks like one triangle, but there's like a little triangle inside of it. Same over here, you're going to look at this large triangle and the smaller triangle inside of it and see if you can prove them similar by one of the postulates or theorems we just went over. Please push pause now so you can try that out and then come back for the answer. So here are your answers. We have the 80-degree angles, so that's one set. And then angle A is shared by both triangles. So that's the reflexive property we've gone over. So that's congruent. So I have two sets of angles congruent. First one, second one. So I can say the triangles are similar by AA similarity. When we're over here, again, we have that shared angle by reflexive. And remember, I'm comparing the small triangle to the large triangle. Okay? So I have 6. That's the smaller between 6 and 10. And notice the big lines here, I'm comparing the entire side of the triangle. So I'm going to compare 6 with 9 and 10 with 15. When I reduce those ratios, I get a 2:3 for both. So these are similar by SAS similarity. All right, for this top one, you check your notes. You have to add these numbers in. They were missing in your notes. We are comparing this triangle up top and the triangle on the bottom. Can you prove that they are similar? And if so, by what? Down here, we're going to find the value of the variable. Don't forget these little triangles mean that the lines are parallel. Remember what you know about parallel lines. So please push pause and try this now. Here are your answers for this. Again, you can push pause, you can look through. Again, in the top one, making sure I compare small to small, medium to medium, and large to large. In the bottom triangles, if again you're not sure which ones to match up, which one's across from this? 6. In the small triangle, it's 6. In this large triangle, it's 8. So what I usually start with these is I will write all the ratios out to start. That's what I did right here. And then I look for that scale factor we talked about. Over here, same idea. I wrote the ratios of all the sides, and that helped me to say 4 to 7 is the scale factor and use that to solve for y and to solve for x. Again, push pause so you can take time to go over these. All right, now try these two. I'll push pause. Please push pause now. And you can see your answers here and how I've marked them. Okay, and if you need those answers again, push pause. And if you aren't sure of something, write that down in your notes, what you're not sure of. All right, there are 3 triangles here which are similar. My suggestion, because they're oriented differently, is to start by writing an S next to the smallest side, an M to the medium side, and L for the largest side. Do that for all 3 of these. That'll help you organize your ratios. There's only 2 that will be similar. Okay, not all 3, so I'll give you that hint. And once you find, you'll be able to do this too. Remember, when you're working this out, you need a scale factor. Please push pause now. Okay, you can see my answers here. Again, look how I labeled it, small, medium, large. And again, when I compared this one and this one, I did my smallest, I did my medium. Right away, my ratios did not work out. So I stopped there and was like, they're not similar. Then I compared the left to the right, and I got all of the same ratios. So those are similar by SSS similarity. They're talking about a triangle that is not drawn, but it is similar to triangle RST. It says the shortest side is 12. So how do I figure out the scale factor? Well, I need to find the shortest side of this, which is 24. Compare that with 12. How did I know to match 24? It said it was the shortest, so I'm comparing it with the shortest of this triangle. And once I have that ratio, the scale factor, I can find any of the sides I need. Okay, give these a try. Again, look at the letters to see how they match up. And over here, I know that gets confusing. Again, use that trick of putting S on the smallest, the medium, the large, and then small, medium, large on the other one so you match them up correctly. Please push pause now. All right, here are your answers. Again, in this triangle, in case you weren't sure which ones to match up, 24 is the smaller of these two. 18 is the smaller of these two. That's how I knew to match 24 and 18. And this one, I did it in different colors. That 12 is shared. It's the smallest of one triangle, but the medium of the other. And you can see how I set that up. All right, last one is here. If you're a little confused, don't worry. Just remember, you're always setting ratios up to be equal. So it'd be height to shadow equals height to shadow. So go ahead and push pause now. And here is the answer. Please remember that 5 feet 4 inches is not 5.4 feet. That's not the same thing. So I changed feet to inches to get 64 inches. Inches to inches, this would be feet to feet. And you can see how I solved that. All right, you can rewind or push pause anywhere you need help and then check the announcement for more information.